Hello viewers, welcome to TV Math Hub. Today we are going to handle Wakisha 2025, specifically number 8, which says integrate x tan inverse x with respect to x. So we are going to see how we deal with such numbers when you're given integration. So they are telling us to integrate this with respect to x. We are going to use integration by parts. We know integration by parts. When given integral of u dv by dx, dx will be equal to u v minus integral of v du by dx with respect to dx. So what they have given us is we are integrating x tan inverse of x dx. But on these two, we have to choose which one is a u and which one is the dv by dx. So we are going to use this word L-I-A-T-E. These factors are grouped into two. So they have given us x and this. So we should know which is x, which is tan inverse of x, according to this word. The L stands for log, the I stands for inverse, the A stands for algebra, the T stands for trig, and the E stands for exponential. So when I look at what is given to me, x is algebra, then tan inverse is inverse. So they have given me such a pair, meaning that if I fit it in integration by parts, this one is my u and this one is my dv by dx. So we come and say, let u, from what we have, u is the inverse, so let my u be equal to tan inverse of x, and the dv by dx equal to x. So when you differentiate du by dx, you will get 1 divided by 1 plus x squared. And when you integrate v with respect to x, you will have x squared divided by 2. So we come and substitute in our integration by parts. So it will imply that the integral of x tan inverse x dx is the same as having my u times v, which will give me x squared divided by 2, my u, which is tan inverse of x, then minus the integral, my v is x squared divided by 2, then times du by dx, which is 1 divided by 1 plus x squared dx. So this one has no integral. We are going to deal with the one which is having the integral symbol. So it implies that the integral of x tan inverse x dx is the same as having our uv was x squared divided by 2 tan inverse x minus, where I'm having integral x squared over 2 times 1 divided by 1 plus x squared, I'm going to pull out the constant, which is a half. So I will have 1 over 2 integral, I have x squared divided by 1 plus x squared dx. So I'm going to first deal with this. So the integral of x squared divided by 1 plus x squared dx. When you look at this, the degree of the numerator is 2 and the degree of the denominator also is 2, meaning that this is an improper fraction. So I deal with it how? By long division. So if I use long division, it will imply that x squared divided by 1 plus x squared is the same as having 1 plus x squared. I'm dividing x squared. So if I want to get x squared under x squared, I will need a 1. 1 times x squared is the same as having x squared. When we subtract, I will have 1 times x squared, I will have x squared. Then 1 times this one, I will have a positive 1. So when we subtract, we shall remain with this and this will cancel, I will remain with the negative 1. So x squared divided by 1 plus x squared is the same as having the quotient, which is 1. Then we go to this, we will have negative 1 divided by the divisor, which is 1 plus x squared. So instead of having this, I'm going to replace it with this. So x squared divided by 1 plus x squared dx is the same as having 1 integral of 1 with respect to dx minus the integral of 1 divided by 1 plus x squared dx. This will give me, when you integrate 1, what do you get? You get x with respect to x. When you integrate 1 with respect to x, you get x, then minus the integral of 1 divided by 1 plus x squared is the same as having tan inverse x. There are no limits, so I add a constant c. So for what I've got for this, I've got this for the integral of this. So I will get this whole thing, I substitute it in my major integral. So this means the integral of x tan inverse x dx is equal to x squared divided by 2 tan inverse x minus a half. Where I have the integral of this, I will substitute with what I've got, which is x minus tan inverse of x, then plus a constant c. So I will end up having x squared divided by 2 tan inverse x minus a half x, then plus a half tan inverse x plus a constant c. Therefore, the integral of x tan inverse x dx is equal to x squared over 2 tan inverse x minus a half x plus a half tan inverse x plus a constant c. However, this can be simplified further to, it will be equal to x squared plus 1 divided by 2, since we are grouping like terms, of tan inverse x minus a half x plus c. So the integral of x tan inverse x dx will be equal to this expression. Yeah.